All right, so this video is about permutations. And we're going to talk about that in just a minute. But let's first talk about when they're useful. All right, so sometimes you'll be given a bunch of objects and you want to arrange only a few of the objects. For example, here's an example. There are 10 people in a competition. How many ways can the top 3 be ordered? All right, so you got some competition. And you got 10 different people trying to win it. But we only want to know how many different ways can the top 3 be ordered. So we got 10 people to choose from. So technically there's 10 people that get first place. 10 different people to choose from for first place. Only one person going to get it, but 10 people to choose from. And if that person got first place, there's only 9 other options of people to choose who can get second place. And of those who have already been selected, there's only 8 other options to choose from for people who can get third place. So the number of different ways is 10 times 9 times 8, which is 8 and 9 is 72, so it's 720 ways. You can rearrange that. All right, so this is one type of way of using counting principles and so forth. All right, let's go to another way. And basically what this is a permutation. And let's talk about permutation now before I go any further. All right, so a permutation is an arrangement in which order matters. Really important to recognize order matters there. The formula for it is M choose N. Hold up, change that to N. And basically it's going to be M factorial divided by M subtract N factorial, where this is your total options, and this is the number you want, the number you're choosing. Choose from the set. So is you got total number of options, and then this is the number you want to choose out of the set. So think about the last question. It's permutation, and we had 10 total options, and we wanted to choose 3. So it's permutation of 10, choose 3. So we've been 10 factorial divided by 10 subtract 3 factorial, which would be 10 factorial divided by 7 factorial, which basically means 10 times 9 times 8 times 7 times 6 times 5 times all those other numbers divided by 7 times 6 times 5 times all those other numbers. So basically you should recognize that these 7s cancel, 6s cancel, 5s cancel to be 1s, and all those other numbers cancel to be 1. So you basically just left with 10 times 9 times 8, which is what we figured out was 720, without actually knowing what permutation was. So can you answer some questions about our permutation without knowing the formula? Absolutely. So anyway, that's what a permutation is, and let's look at another type of question that involves a permutation. But I will get any of that as a note that you didn't already know. All right, moving on. All right, so there are 12 movies playing at a theater. How many ways can you watch 2 of them? All right, so you're going to watch 2 movies. This is your first movie. This is your second movie. So we got 12 movies to choose from. That means I have 12 options for my first movie. If I want to watch 2 of them, my second movie's got to be a different movie. So after I watch my first one, I only have 11 options left for my second movie. So my answer is 12 times 11, which is 132 ways. If you thought about this as a permutation, this is a permutation of 12 choose 2, which is equal to 12 factorial divided by 12 subtract 2, so that's 10 factorial, which you should find to be 12 times 11, which is 132. Going on. New example. But as always, copy anything down that you didn't already know and make sure there's a note. All right, this topic is about specific positions. All right, so frequently when arranging items, a particular position must be occupied by a particular item. The easy way to approach these questions is by analyzing how many possible ways each space can be filled. All right, so go ahead and copy down this page, this note, and then I'm about to erase it. They talk about how it actually can be applied. We'll pause the video and copy down this. And think about what it says too. All right, moving on. So how many ways can Jay, Daniel, Emily, and Charlie be seated in a row if Charlie must be seated in the second chair? All right, so let's think about this. We've got 4 students. How many people must be in this chair? Well, this is just Charlie. Only one option for that second chair. So if that's true, how many people we have left to choose from for the first chair? Well, Charlie's already seated, so you still got Jay, Daniel, and Emily left to choose from. So you got 3 choices for the first chair. After that person sat down, you got 2 choices for the third chair, and it leaves you with 1 choice for the last chair. So the answer would be 3 times 1 times 2 times 1. This is 6 ways. If Charlie had to be in the second chair. So this is one way when you have specific positions. Let's look at another example. Well, I'll get this as a note if you need it. Okay, it's a new question. How many license plates can a company make if each plate has 8 alphanumeric characters and the first and last character have to be a letter? Alphanumeric, it's a new word, that means letters and numbers. And also, that's it just means letters and numbers. So basically we have a license plate. This is my license plate. It's a Georgia license plate. And on this license plate, you have 8 characters. So 1, 2, 3, 4, 5, 6, 7, 8. What's very specific about this license plate is the first one must be a letter, and the last one must be a letter. All right, let's assume we're using letters in the English language, and in our language we have 26 letters. So we've got 26 letters to choose from our first blank. It didn't say they can't be the same letter, so because of that, my last blank, I got 26 letters to also choose from. So here, I can have anything I want. It could be letters or numbers. So we got 26 letters, and for one space, how many numbers do you have to choose from? Well, it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0. So that's 10 options for numbers. 10 numbers. So together that's 36 options. So we got 36 options for this space, 36 options for this space, and 36 options for all the other spaces. So our answer is 26 times 36 times 36 times 36 times 36 times 36 times 26. It's going to be a really big number, so I'll write that out. So simple way of writing is 26 squared times 36 to the 6th power. So that's a condensed way of writing it. You could also call it 1.47 times 10 to the 12th power. Or it's going to be exactly 147,150. Your calculator told you 1.47 e to the 12th. That means 1.47 times 10 to the 12th. And basically, you would take this decimal space and move it over 12 times. So move over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And since it didn't give us these numbers here, I just put zeros in their place. So we can't get it exact because our calculator won't actually go out that far. we can get really, really close to it. So it's going to be a comma here, comma there, comma here, comma there. So it's hundreds, thousands, millions, billions, trillions. So it's 1 trillion, 1.4 trillion different ways they can come up with license plates if that's what the requirements were for that license plate. All right, going on, new example. And also, I'm about to erase this. Okay, so how many ways can you arrange the letters in the word consonants if it starts with a consonant and end with a vowel? So let's first see how many letters are in this word. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. And then I got to decide how many vowels and consonants there are. So A is a vowel, U is a vowel, I is a vowel. So it's 3 vowels. 3 vowels. Means the rest must be consonants. So 6 consonants. All right, so if that's the case, it says the first one must be a consonant. So I have 6 options there. Consonant. The last one, this ends with a vowel, so the last one must be a vowel. I have 3 options here. All right, those are 2 letters already taken from all of our options. So we had 9 letters to choose from, but the first and the last one have to be already selected. So I only really have 7 letters for this next space. And then I have 6 letters for this next space, and 5 letters for the next space. So 5, 4, 3, 2, and 1. And our answer is whatever that product is. So this means we got 90,720 ways we can arrange it given those requirements. All right, so I think that's it. That's all I have. Good luck.